So first up, I'm going to welcome Don, and he was one of our Hackfest workshop leaders, actually. And he's going to talk a little bit about their workshop on the KINA Graph. And if I've pronounced it wrong, he will correct me. Thanks, Don. It's right. Woo! I did.
Our workshop was actually a bit more of a demo. We're not quite ready yet to let you guys take it apart. We just got it put together. So we are the Provincial Archives of Saskatchewan, so thanks all of you library people for letting us come to your event. Preservation management is our unit, and we work with special media, digital records, documents, photos, etc. Little background, we have thousands of reels of film, most of it 16 millimeter. That technology, if you've seen Steenbecks or projectors and whatnot, is scarce and hard to maintain, and probably doesn't work. Outsourcing a lot of our films to commercial companies, it's expensive, very expensive. So consequently, a lot of our researchers are not using our films. We want to promote access. We also want to ensure that we can preserve those records. So we were looking for a means to digitize that collection. Open source software and a lot of DIY and maker hardware has actually created a wonderful environment, a culture community for solutions for, in this case, digital replication of our film. We've built something called the KINA Graph. It's an open source deck designed by Matthew Epler, and he's, I think, at New York University. Here's a screenshot from their page. I don't think you'll find anything else under Google under KINA Graph. I think there might be a film that was made. Here's a picture of his prototype. This is with 16 millimeter film, or 35 millimeter film. We built one of those, made a number of modifications and improvements, and I think those of you that were here yesterday, even if you weren't in the workshop, would have seen that. Here I am in one of our labs here. You'll see there's all sorts of bits. A lot of these were purchased from McMaster Car. We've got some things coming from China, Amazon, all sorts of places. That's one of the great things that Epler did with this is putting together a source list and did a lot of the nasty legwork for that. Here was our build just before the version that we brought. There's film. There's a gate assembly here that you can see on here that we passed the film through. We actually used an old microscope mount to provide us with at least 2 degrees of freedom for adjustment of our camera, which you don't see mounted on the top of this. Control software, using Arduino microcontroller for this. Once the frames have been captured, actually if we have a look, here you'll see there's a bunch of sensors. We have motor control for transport. There's a camera, has to be remotely controlled. And that's done by way of this Arduino software. Post-processing, once we capture their scans, there's some geometric corrections. We get skewing, we get rotation, both fine and coarse rotations happening there. Some image processing that may be necessary to compensate for some light or color differences. As frame extraction, which is done with, I don't know if anybody's used processing.org. Sort of a Java-based. In fact, I think the Arduino IDE is really based on processing. Stabilization, there's various softwares that we've used for that. In fact, we've used Blender for that, a 3D modeling software, but it's great. And then the final video encoding is FFmpeg. Here at the Hackfest, we brought our KINA Graph up, all in pieces. It took a little while to assemble. First part of it, presentation and discussion. We talked about our build process, a lot of the issues and problems that we encountered, some of the improvements that we made, and we still have some to make. A great demo. I had a short 16 millimeter film. It actually worked, and you can ask somebody. It did. We also well, fortunately and unfortunately, also demonstrated some of the defects too. There's still some synchronization problems and whatnot. Our documentation of our work and status, we will be posting a lot of this. You go to the YouTube, look for Provincial Archives of Saskatchewan. You'll see the films that we've produced for World War I, but you're also going to be seeing the results of our work, and I think we will be getting a little bit of information from this Hackfest. So, good. Thank you.
Great, thanks very much, John. So next up, we're going to have John from USask pop up and tell us a little bit about the Drupal workshop that he ran. I think. Do you want to go later? I can pull someone else up. Okay. I don't know, man.
Will it blow anything up? Oh, I don't.
You don't have HDMI. I think we're going to have to just listen to your words and build us a word picture.
I'll do that. I'll look at the pictures and describe them. So what we did in the Drupal workshop is, well, it was a bit of a tough one to put together because Drupal can do a lot, and there's a lot of options and a lot of features, and everybody's coming at it from a different angle. So we started out, I used Drupal multi-site to create a multi-site for every person in the group, and I said you can go nuts and play. So we experimented with creating content models and what that can give you, and we experimented with managing the people and roles and permissions to see what you can do with that, and we looked at how to move around blocks in the page and to install new themes and install new modules. So the morning was doing that, and everybody kind of built their own little website. They built a content model, they added some content. Sarah built some books and you can see her different book content types, and then she was able to create a menu system to link to those things. So in a morning, like, it was 2 hours, and everybody had kind of their own custom, a start on a site. So it was with somebody there kind of to provide some confidence. Drupal's pretty easy. It's also can be pretty confusing. So. And because I'd said when I proposed this that we would build a module, we had to go do some coding. So building a module in Drupal 8's relatively simple. A lot of it is just config files. It uses YML files to define your routing system and your menus, and a tiny bit of PHP to put some stuff to screen. And by the end of the afternoon, everybody had written a module, their own little hello world. We just followed what was on the Drupal.org site. And so hopefully the people that showed up and attended are a little more comfortable with Drupal and can go and use that in their institution, or not run and hide when they're asked to work with Drupal. So that's sort of what the session was about. So.
That's great. Oh, I am not that tall. Great. Thanks, John. Next, I'm going to invite Mita up to talk about her group and what they did with Raspberry Pi.
That's it? Yay! Which one do you want? The first one. I have the whole story.
Great.
So hello, everyone. When I saw that there was a workshop for Raspberry Pi, I knew that that was something I was very much interested in, because I am guilty of owning a Raspberry Pi and not doing anything about it. So one of the things that when we started the morning, we had a conversation led by Daryl about all the uses that he thought of for potential projects that Raspberry Pi could use. So I think there might be other groups that will talk about potential for like gate counts or humidity. And so we broke out into several groups, and our group was a table full, and we had a Raspberry Pi in front of us. And so the working project that first came that I suggested for my own selfish reasons was it would be really, I've always wanted a button that you could press, like a Staples That Is Easy button. And there's a space that I'm involved with, and only certain people have the keys. So it would be nice if someone who had the keys would come into the space, tell everyone that it's open by hitting the "that is easy" button, and then it just tweets a little message to the world saying that, the room is open. So that was the working case that we went with. And so in order to do that, there was sort of two parts to it. So one was, can we get a little Raspberry Pi, which is a very small computer, which has wireless capabilities to talk to Twitter. And that actually was the most Twitter was, not surprising if you know Twitter, that was the worst part. They have an authentication part that it took several librarians to swear, and, well, not swear, but just to shake their mighty fists, because the documentation, essentially the documentation that we were working with had not caught up with changes that Twitter had made. But I'm really happy to say that our group collectively figured out that authentication with some help, and so then we were able to make our little bot communicate to Twitter. We called it the Access FOMO bot. FOMO means fear of missing out. And before before Access happened, there were some people that expressed that they were feeling FOMO about Access, that they were afraid that they were going to miss out on good times at Access. And so this was I don't know why we decided to make an Access FOMO bot, but we did. Then you'll see that. So unfortunately, we've lost the very discrete timestamps, because the next step that we did was, okay, well, how can we trigger our bot to do something? And we hooked it up to a light monitor. And it's unfortunate that the timestamps aren't here, because once we hooked our light monitor from the Raspberry Pi to Twitter, or light and motion monitor, we exceeded our Twitter. We spammed Twitter. It was a very, very sensitive light monitor, and so you can't see that. But we got pushed out. We didn't get permanently kicked out of Twitter, but just partially kicked. And so we were excited about, well, what other things could we do to use this little monitor? So this essentially what you could use this device for is, instead of having a program running on a full-on server, you could just think of your little device as a sort of active thing that could talk to the world as long as it has a trigger. And so the next thing we played with was a camera. And that's pretty much an accurate shot. So we were actually trying to take a picture of a little robot there. And again, one of the things I really appreciate of this workshop is that, the first thing I really appreciate was that just to understand how powerful this camera was. It's a very small device, and when you realize what capabilities you can do, you can hook it up to all sorts of different types of sensors, and then communicate to the world through wireless. All sorts of ideas start triggering in your head. So that's our team. Victorious. And the code is readily available. So, and that's kindly, and I will tweet this code, but we have it available on GitHub. So you will see just, again, once this sort of scary authentication dance is there, and as I said, we've got that working, so this is probably your best bet. You'll see that the actual getting the camera stuff to work, difficult to see here. There are little libraries that make it actually remarkably simple. So the thresholds, as I said, one of the things I really appreciate about the workshop is that it really reduced my fear threshold, and I have all sorts of new ideas of what I can do with my Raspberry Pi back home. Thank you, everyone.
Thanks so much. The cheers coming from this room when they got it to work were awesome. I was sitting out in the hall. So next I'm going to introduce another person who was working on the Raspberry Pi workshop and has a bit of a different story to tell. So I'll welcome Andrew up front now. I can't, my hands are full.
Thank you very much. We worked on a Raspberry Pi project that involved gate counting. And I was particularly interested in this project because, coming from Edmonton Public Library, we have quite a few gates and 20 branches. And I've built software to ping these gates and collect information. Now, these gates are manufactured by a company that will remain nameless, but whose initials are 3M. And it's very black box. So when I asked the engineer, how do I collect gates remotely or gate counts remotely? He sent me a note back saying, well, you just open a socket and you send this byte sequence, and you'll get two numbers back separated by a space, and those are your in and out counts. Okay, so I built a system that does that, but these gates are producing a lot of very noisy information. We're getting regular gate counts on days that the library we know are closed. So there's a lot of problems with that. So when I saw that they were building a gate counter with a Raspberry Pi, I got very excited. And so, as Mita was saying, we had a tiny little camera on a little single-core Raspberry Pi. We managed to get some video capture, and that was pretty stout work, considering we had to compile NumPy on a single-core little microprocessor. But it was a huge learning experience. And I guess the point of it is that if you don't have any experience in this, but you have a curiosity about it, come to the Hackfest, because, I mean, we were a group, but we were a director, a librarian. I've written in Python before. Another guy used VI quite a bit. And I don't know how many of us, I don't think any of us really had a lot of experience with the Raspberry Pi. I've certainly never used it before, I'm embarrassed to say. And it was just a really good bonding experience, and we learned tons from each other. So I would encourage you, if you don't have experience, don't let that be a barrier to you. Come out and try it. All right. Thanks.
Okay, and our final Hackfest report back is going to come to us from Dale from Sales. And he did some of the more traditional hacking, I guess. I don't know.
Sorry, if I plug this in? An option?
It's tricky. Yeah?
All right.
Might as well try it. What do you got?
Oh, okay. HDMI?
Yeah.
Okay. Oh, okay. There you go. Let's see how this works.
Everybody hold your breath.
Oh, it did something.
Because it looks great on here.
All right. Well, okay. Ours was related to our presentation yesterday morning. It was basically we had a group who was doing a local installation of the Elastic Stack, so the three components, Elasticsearch, Logstash, and Kibana. There are pretty decent tutorials on the Elastic website, and we were using those, and they have binaries for the system. I installed mine through Homebrew, the Mac package manager, and ran into a bit of trouble there with Logstash. But there's also sample data on the Elastic Stack or the Elastic Co website, and there was a cool Shakespeare graph that I was going to show you, where we found out that the character of Gloucester in Shakespeare's entire corpus of plays speaks the most in about 7 different plays. I assume it's a different character in each play, but as well as the messenger, who speaks in about 15 or 16 plays. But it had a line count of how many lines they spoke. And of course, it's all clickable. It would have been great to show you this, but you could limit by the play and then see the line of each character in each play. From there, we were kind of just thinking of what next, and Greg Harkelman was very kind and gave us a copy of the metadata from Saskatchewan History Online. So we had 127,000 records or so that we could ingest with Logstash, and we spent the rest of the day writing a Logstash file to ingest that. And how far did we? Where is Shane here? Did Shane have to leave? Okay, Shane and Scott made the furthest progress with that. We were all kind of working on files, but they managed to ingest all the information, but there was a problem with one of the date fields, and that's the tricky part is working out the mappings on the date fields sometime, and I think it's probably something we'll look at on Monday morning and maybe try to ingest, and then we'll send you a link for it. Yeah, put it up on a server somewhere and send you it. So because I'm sure there'll be some really interesting stuff there. So, all right, thank you.